Most people trying to break into cybersecurity will never get hired, and it is not because they are not smart enough. It is because nobody gave them the actual sequential path from zero to the top. They download Kali Linux, run a few tools they do not understand, hit a wall, and quit. This video is the path they were never given. 13 phases. Every prerequisite. Every tool. No steps skipped. And at the end, how to use AI to compress years of this into months without cutting corners. Phase 1 is computing foundations. Binary, hexadecimal, CPU architecture, and the boot process. Most people want to skip this. Do not. Understanding memory at the hardware level is the difference between someone who runs exploits and someone who writes them. Start here. Von Neumann architecture, how RAM and CPU registers interact, and what actually happens from power button to login screen. Phase 2 is network engineering. The OSI model, TCP three-way handshake, DNS, ARP, DHCP, and HTTP headers. You must be able to open Wireshark, capture live traffic, and read what every packet is doing. Not just know the theory, actually read it. You cannot attack a network you cannot read. This phase is not optional and it is not boring. It is the foundation every phase after this depends on. Phase 3 is operating system internals. Linux file system hierarchy, file permissions, SUID binaries, Windows registry structure, and sysinternals. You need to understand why the /proc file system in Linux exposes running process memory. You need to understand why the registry is where attackers hide persistence. These are not abstract concepts. They are the mechanics of every attack in phases 7 through 13. Phase 4 is programming. Python for automation and custom tooling, Bash for Linux scripting, PowerShell for Windows environments, and C is non-negotiable. You must understand pointers, memory allocation, and manual memory management. Every advanced technique in this roadmap, shellcode loaders, process injection, ROP chains, kernel drivers, requires understanding how C manages memory. There is no way around it. Phase 5 is reconnaissance. Passive OSINT first, Shodan, Multigo, Google Dorks, certificate transparency logs, Amass, and Subfinder. Then active scanning with map. Learn every flag. SIN stealth, version detection, OS fingerprinting, and then map scripting engine. A professional does not touch an exploit until they have mapped the entire attack surface. Most beginners do this backwards and miss the easiest entry point. Phase 6 is web application security. The full OWASP top 10 done manually before you touch a single automated tool. SQL injection, XSS, SSRF, IDR, command injection, JWT manipulation, and LFI. Every one of them manually in Burp Suite first. The reason is simple. If you cannot exploit it by hand, you do not understand it. And if you do not understand it, you cannot explain it in a pentest report. Phase 7 is network exploitation. Reverse shells, bind shells, Metasploit, Venom, and password cracking with Hashcat and John the Ripper. Remember why reverse shells beat bind shells. Corporate firewalls block incoming connections. They almost never block outbound traffic on port 443. That is not a trick. That is network architecture working exactly as designed. Understanding the reason is what separates a professional from someone copying commands. Phase 8 is privilege escalation. Rooting Linux boxes using linps, GTFO-bins, and kernel exploits. Getting system on Windows using WinPs, token impersonation, and DLL hijacking. Do not just run the tool and copy the output. Read every line. Understand why each finding is a vulnerability before you exploit it. Platforms for phases 5 through 8. Try hack me offensive paths and hack the box easy to medium difficulty machines. Do not move to phase 9 until you can root machines consistently. Phase 9 is active directory domination. LLMNR poisoning with responder, Kerberoasting, ASRAP roasting, pass the hash, golden tickets, and DCSync. 90% of Fortune 500 companies run Active Directory. If you cannot enumerate and exploit a Windows domain, you are not a professional penetration tester. Use Bloodhound and Sharphound to graph every attack path. The visual representation of domain trust relationships changes how you think about enterprise networks permanently. Phase 10 is red team operations. Cobalt Strike, Sliver, or Havoc for command and control. Malleable C2 profiles that make your beacon traffic look like normal Amazon or jQuery requests. Redirectors to hide your real server. Domain fronting through CDNs, age domains with real categorization records so your infrastructure does not get flagged. This is where a pentester becomes a red teamer. The mindset shifts from finding a vulnerability to operating inside a network without being detected. Phase 11 is AV and EDR evasion. This is where most people's knowledge completely ends. Metasploit default payloads get flagged by CrowdStrike, SentinelOne, and Microsoft Defender within seconds. You need to understand why and build around it. Direct syscalls using syswhispers to bypass user mode API hooks. AMSI bypass via in-memory patching. Process hollowing to run your code under a trusted system process. Sleep obfuscation to encrypt your payload in memory while it waits. Phase 12 is exploit development. x64 assembly, dynamic debugging in x64 for DBG and WinDBG, GIDRA for reverse engineering, and ROP chain construction. ROP chains exist because modern operating systems mark memory regions as non-executable. A ROP chain reuses legitimate code already in memory to bypass that protection entirely. Then heap exploitation, use after free vulnerabilities, and fuzzing with AFL++ to discover the 0 days that nobody else has found yet. Phase 13 is the ghost level. Kernel exploitation using ring 0 access. Bring your own vulnerable driver attacks that physically disable EDR at the kernel level before it can report anything. Direct kernel object manipulation to hide processes from every monitoring tool on the machine. Custom C2 frameworks built from scratch in C or Rust with no public signatures. UEFI bootkit development that survives a full OS reinstall because the persistence is written into firmware before the operating system even loads. That is the path. Now here is how AI changes how long that path actually takes. Use Claude or ChatGPT as your personal tutor for every single phase. Every concept you do not understand, ask it to explain it at exactly your level. Specific prompt that works, you are a cybersecurity mentor. Explain how Kerberoasting works as if I understand Active Directory basics but have never attacked it before. Generate 5 practice questions after. Use AI to guide your lab sessions without giving you the full answer. Feed it your LinPs or map output and ask it what the most critical finding is and why, without telling you the exploit. Use GitHub Copilot when writing shellcode loaders and automation scripts. It does not write the exploit for you. It removes the syntax friction so you focus on the logic. Use AI to translate GIDRA assembly output into plain English. Paste a disassembly block and ask it to explain what the function does, what registers are being manipulated, and what the calling convention is. Use Claude specifically to write professional penetration test reports from your raw technical notes. A polished report is what gets you hired and what gets you paid. AI compresses a 4-hour writing task into 20 minutes. Use AI to prepare for certifications. Prompt: generate 20 CEHV13 practice questions on Active Directory attacks, then generate 20 more on EDR evasion. Cover every domain before you book the exam. AI does not replace the learning. It removes the friction that makes most people quit before they ever get good. The complete roadmap PDF covering every phase, every prerequisite, every tool, and the full AI acceleration protocol is completely free. Link is in the description. If you want personal guidance on exactly where to start based on your current level, send me a direct message. Free, no catch, no course to sell. Let us get you on the path.